In this video, we're going to go through percent composition. The essential question that we're going to answer is how can the percent composition of a compound or hydrate be determined, and why is it important for chemical analysis? So percent composition refers to the percent by mass of each element in the compound. And we find percent composition by taking the mass of each element in the compound and dividing it by the total mass of the compound. And then because it's a percent, we're going to multiply that number by 100. So let's look at an example. Let's do water. Water is a really simple example. So for water, we're going to begin by finding the molar mass. Okay, so step one is going to be finding the molar mass. So to find the molar mass of water, we're going to take each of the elements. So we have hydrogen and we have oxygen. Hydrogen's 1.01 and oxygen is 16. Now, there are two hydrogens in H2O, so I'm going to multiply that by 2. And now I'm going to add these numbers up. So 2.02 plus 16 will give me 18.02 grams per mole. Okay, so that's my molar mass. Step 2 is going to be my percent composition calculation. And again, we find percent composition by taking the mass of each piece and dividing it by the total. So let's find the percent composition for hydrogen. So hydrogen is 2.02 grams in our compound. Not just one hydrogen, but all of the hydrogen is 2.02. And we're going to divide that by the total mass of water, which is 18.02. So dividing it by the molar mass. And then we're going to multiply that by 100. So when I do that calculation, I get 11.2%. We're going to do the same thing now for oxygen. So oxygen is 16 grams, and I divide that by the molar mass, which is 18.02. And I'm going to multiply that by 100 to get me 88.8%. And that's it. So for percent composition, we basically just break down every single element that's in a compound and tell or report out how or what percent of the total compound is that element. And we do it by mass. So another example is this. This is a hydrate. So when you see the word hydrate, you probably think about drinking water, and that's exactly what hydrates are. It has to do with water. So there's water attached to our compound here. So here we use this dot, which again, if you think about math, it's being multiplied. It's part of that compound right there. Okay, so a hydrate just means that it includes water. So again, step one is going to be finding our molar mass. Okay, so we have copper, we have sulfur, we have oxygen, and we have water. Now, you could break this down even further into hydrogens and oxygens, but I'm going to leave my hydrates separate. Okay, and you'll see why. All right, so copper, if I look it up on the periodic table, is 63.55. Sulfur is 32.07. Oxygen is 16, and there's 4 of them in our compound, not including the water, so that's going to be 64. And we actually found the molar mass of water before, so the molar mass of our water was 18.02. But we have 5 of them in our compound, so there are 5 waters in our compound here, so I'm going to multiply that by 5. Okay, so 5 times 18.02 is going to be 90 39.10. Okay, so let's find the entire mass, or our molar mass here. We add all those up and we get 249.72 grams per mole. Okay, so this is a hydrate analysis. So a hydrate analysis, we want to find out what percent of our total compound is water. Okay, so in our previous example, we did percent composition and we broke it down by element. This is similar. It's still percent composition, but we are doing hydrate analysis. So we only care about the water in this example here. Okay, so it's still percent composition, but I'm doing a hydrate analysis. Now, it wouldn't be wrong to report out the percent composition of copper, sulfur, and oxygen here, but I'm just going to do our hydrate here. So the total mass of water is 90.10 in this compound, and the total mass is 249.72, and let's multiply that by 100. So when I do the math here, it's 36.1%. So that is the mass of just the water in our compound. And that's pretty much it for percent composition.